Hi, my name is Jeff Gibson, and I'm here today to talk to you about the used car price prediction model for Cars for You. A big problem that management faces is the mispricing of cars that the company sells. If your prices are too low, you'll have quick sales, but you're losing out on incremental profits on each vehicle. If your prices are too high, you're going to have slow sales and lose customers to other dealerships that sell the same car. Both of these scenarios represent a loss of revenue for the company. Our solution is to offer a data-driven approach that's going to use a supervised learning model that's going to learn from existing data that the company already possesses. This is going to mean time savings for management because they'll spend less time researching the price of vehicles. And our pricing strategy is going to be a predictive tool using our model. We're also going to recommend data improvements that will help this and future models. And all of this should result in higher revenue for the company because we're going to have more efficient pricing that's going to better match supply and demand dynamics in the marketplace for used cars. We faced several challenges while building our model. We found that 86% of new price data was missing, and this was a potentially important independent variable for our model, but we simply had to drop this feature because of too much missing data. We also found that 17% of our observations were missing price data, so we had to drop these observations as well because price is our target variable and we needed that in order to train our model. We also found that there were over 2,000 unique values in the name category because it combined the brand name, the model name, and other car features. And we'll talk about how we dealt with that in a moment. We only found one outlier, and this observation was easily dropped. And there was a small percentage of zero values that we adjusted using the mean for each respective variable. And you can see this in our appendix. We learned some insights during the data analysis phase. We found that power and engine variables were saying essentially the same thing because as you increase the engine size of a car, the horsepower typically goes up. So we found that these two variables were highly correlated, and engine was also at the top of our list of inflation factors, and we ended up dropping engine size due to its potential influence with other variables in our model. In order to deal with the name issue, we derived country instead of using brand name of the vehicle because we felt that companies like Ford and Chevy, they have cars in economy, low-priced vehicles that they sell up to high-priced SUVs. And we thought that country had a little more important significance for our model potentially. We also divided the sales locations into regions because we saw a pricing pattern that was similar for two of the southern offices. And lastly, we consolidated some of the options in fuel type, owner type, and the seats categories. There were too many options in these areas and that had very little data, so we consolidated these to make our model more efficient. So with all this in mind, we trained and tested several regression models, but we found that the random forest model offered the best performance with the highest R-squared value and the lowest mean absolute error, meaning it gave us the best predictability. In terms of feature performance, there were 5 variables that accounted for about 95% of the model's predictability. The most important feature was power, followed by age, and it dropped off significantly from there to mileage, kilometers driven, and the number of seats. The model actually predicted a price that was 2.26% higher than the actual price on average. So simply implementing the model price in the future should result in higher revenues for the company. But when it comes to our recommendations, we actually want to take it a step further. We want to management to implement a market clearing price strategy. And this would mean finding the market equilibrium for each car that's sold. And this would maximize the profits for each car and the company as a whole. This approach would take the model price and then mark up the price of each vehicle anywhere from 10 to 50%, for example. And then you discount that price over time until the vehicle is sold. Say, for example, from 1 to 5% per week, depending how quickly you want that vehicle to sell. So on the right, you can see our predicted price compared to actual price. And the diagonal line represents where our model predicted a price that was perfectly accurate with the actual price. And you can see most of our observations lie along that diagonal line. But as you go up in price, the observations, you'll see more dispersion. So that's where this markup is important, because the green diagonal lines that go down towards the x-axis represent the markup of 10, 20, 30, 40, and 50% above the model price. And that's a way of capturing these more expensive vehicles and where our model is under predicting actual price. In fact, you'll see at the far right, there's a observation that data point is a Lamborghini that the model severely underpriced. So you may need a markup of 60 or 70% above the model price for exotic or ultra luxury cars. But this is where management could use their skills and understanding of the market and demand to decide on the markup and discount rate and period that they want to use to sell vehicles. Our other recommendation is to increase data integrity as a firm-wide initiative. We feel it's important to validate all the data that's entered for each car, and there are automated or manual processes that could be put in place to make sure that each car that's sold has accurate and complete data. Then there are also other fields that we recommend to define these cars, such as color, condition, and the number of imperfections on each vehicle. And we'd also, as we mentioned earlier, you need to break up the name category into multiple inputs to account for the brand, the model, and other features you'd like to describe. And lastly, we feel it's important to update our price prediction model periodically, because we will be able to improve the results with more and accurate data and account for some of these new features that we like management to add. So that's it for my presentation today. I want to thank you for your time and answer any questions.